Hey guys, want to build a robot? I just wanted to take a second to say thank you to all of our amazing subscribers. It has been so much fun to try and grow this YouTube channel. We have our Instagram, our YouTube channel, and our website. And, we started ACBR with the goal of helping students and engineers and makers all around the world have a blast building robots. And so it's just been really, really cool to see. And so with that, I wanted to say that this video, if you were a pro, you've been programming Arduino and ESP32 for a long time, this video is probably not for you. This video actually covers chapter 1 of our brand new ebook. So we spent months working on distilling all of our intro to robotics curriculum into one easy to follow ebook. And we're actually giving it away for free. So if you're interested in taking a look at our ebook, it's like 80 pages with tons of fun lessons. We have that for free on our website. And so this video covers chapter 1. And chapter 1 is the very basics. If you're not sure about how to build your own custom robots, you're looking for a little guidance, maybe you picked up one of our kits but you're not sure where to start, then this video is for you. Let's get started. So we're really excited about our new ebook. Like we mentioned earlier, the goal here is to show some examples of the very basics in getting started building custom robots using Arduino. We've actually got a very similar video series coming up soon for another one of our favorite boards, the ESP32. But for this video series, we're going to be focusing on Arduino. So for all of the examples in this book, I'm going to be using one of my favorite Arduino compatible boards, the RF Nano. So for these examples, you could use almost any Arduino compatible board that you'd like. But my favorite, the RF Nano, is really, really cool. So the RF Nano is a standard Arduino Nano with an upgraded micro USB connector and a built-in radio. For some examples on how to use the radio function, we have some awesome videos here on our channel that go over the examples a little bit more in detail. So if you're interested in that, feel free to check those out as well. So this ebook is broken up into 4 chapters: controlling light, controlling sound, controlling motion, and your next steps. So messing with light, sound, and motion is a great place to get started because if you put all of those things together, you've got a robot. So for chapter 1, we've got to go over how to plug in, connect, and upload code to your Arduino, how to control a few basic functions with a single LED, multiple LEDs, and then finally, the RGB LED. Let's give it a shot. So your very first step in getting started is going to be to download the Arduino IDE. Now, IDE stands for Integrated Development Environment, and it's how we write and upload our code. So the standard Arduino IDE looks just like this. Now, there are also tons of alternatives to the Arduino IDE that have more features and definitely have a lot of major benefits. And so if you'd like to, you're welcome to try one of those. But for those of you guys who are just starting out, I recommend getting the official Arduino IDE, as it'll do everything we need it to, and it's really, really easy. So to get the Arduino IDE, you have a few options. Your first option is to download the Arduino app from your app store. Whether you're using a Windows or a Mac, you can totally take that route. But I actually recommend getting the Arduino IDE from the Arduino website. So the first step is to head to arduino.cc and click on the Downloads tab underneath Software. Once you click that, you'll be greeted with this web page here, and obviously they want you to try to use their new web editor. I personally am not a huge fan, and so I would recommend actually downloading the Arduino IDE. So there are a few options here. We could check the actual Windows installer. That way, when Arduino acts just like any other app you have. This allows you to run Arduino off of a folder by itself, which can be useful. And there are a bunch of other options, if you're running this on a Mac or Linux, or if you want to get the official app. I recommend just sticking with the installer, but the other options are not bad, not at all. Once you open up the Arduino IDE for the very first time, you'll be greeted with a screen just like this. So we have some area here to write our code. We've got some menu items up here, a few more buttons that we'll talk about later, and we are ready to go. So believe it or not, the very first thing that I'd like you to do is actually head to the Tools tab. So if I click on the Tools tab right here, I have a bunch of options. And the first that I want you to take a look at is the Board tab. So underneath the Board tab, we have tons of options. And so we need to tell the Arduino IDE what kind of Arduino that we're using. So the RF Nano acts like a regular Arduino Nano, so that's what I have selected here. But as you can see, there are so many other alternatives. Some of these are ESP32 boards, we have some ARM Cortex type boards, and if that doesn't make any sense to you, do not worry about it. You're more than likely going to stick with the Arduino AVR boards. You may be using an Uno, maybe a Leonardo, but like I said, in my example, I'm using an Arduino Nano. The next thing I want you to take a look at is the processor. So you should not necessarily have to change this option. If you're using a new version of Arduino and you have a newer Arduino Nano, that you got within the last year or so, then leave this option alone. If you have trouble uploading, you may want to select the old bootloader, but you shouldn't need to. The next most important thing is to select your COM port. So here you can see I have all kinds of COM ports, and you more than likely won't. You'll see just one, maybe two. But the most important thing is to find the COM port, or the communication port, that you're using with the Arduino. And so this is referring to the actual Arduino and where it is plugged into the computer. So one of the most important things once you click on the COM port is to make sure you have a check mark. If you don't have a check mark on your COM port, then the Arduino IDE doesn't know where to send the code and it's not going to upload. But these are the three most important things that you take care of first. Once you have those three settings set, you're actually ready to write some code. So here we have a new code window. Anytime you start up a new window, it looks just like this. We have a void setup and a void loop. We've got some brackets here that need to hold our code, and we have some comments. Anytime you see this // that's what's called a comment. And a comment is just a note, right? This isn't actual code. This is an area where you can write whatever you'd want. So here we have a note saying, put your setup code here to run once. And that's true. The void setup only runs once. And there's all kinds of functions that we use to set our sketches up, to set up our code that we would write right here. Now we also have the void loop. And as it sounds, the void loop loops over and over and over and over again. And this is where the main part of our code. So a majority of our code is going to live in the void loop. Now, often we have other situations in which we need to create some variables above the void setup. And that code doesn't need to live inside of brackets. But if you're writing code for the void setup or the void loop, you want to make sure that you write your code in between the open and closed bracket right here. So with all of that out of the way, let's go ahead and write our first example. Now, this very first example is going to be very, very straightforward and really simple. We just want to make sure that we have the ability to upload code and that everything is working. So the very first thing that I'm going to go ahead and type is going to be inside of our void setup. I'm going to write serial.begin 9600. Now, that might already seem kind of strange, but let's go ahead and break that down. So when I write serial with a capital S like this, what I'm trying to do is I'm trying to write a command for my serial monitor. Now, the serial monitor is really cool, and we're going to see later down the road that it's super, super helpful. And the serial monitor allows us to see exactly what the Arduino is thinking. It also allows us to print out information. So whenever we have data from sensors and things like that, it becomes super, super helpful. So my command is serial.begin. That starts my serial monitor. And then I have the number 9600. Now, you guys don't need to worry about that too much. 9600 is referring to the baud rate, or the bits per second, and that's like the communication speed. So for the Arduino, 9600 is standard, and you'll see there are other boards that have other communication speeds that they like, but all you need to know right now is that we have serial.begin 9600. Now, we're going to go ahead and write some code in our void loop. So I'm going to start off with serial again. But this time, I'm going to write print. Serial.print. I wrote some code. And now, what's so cool about the serial.print command is that anything you write in between these parentheses, the Arduino will print. And so this is a really, really basic example. Like I said, I've only written 2 lines of code. But what's so cool is even if I only have 2 lines of code, I can still see what happens. And so we're going to go ahead and we're going to upload this code. And once we're sure that we're ready to go, we can go ahead and upload. So the very first step is going to be compiling our code. So we're going to hit this check mark right up here. The check mark in the upper left-hand corner will compile our code. And this will take just a few seconds. And so, if there are no errors in your code, you'll see the message done compiling at the bottom. Now next, we're going to upload our code. So we're going to use this arrow right here, also in the upper left-hand corner. So I'm going to hit that arrow, and that will start the process of uploading our code to our Arduino. Now in reality, whenever you hit the upload button, it'll automatically compile. So technically speaking, if you want to upload, you don't need to compile first. But I just wanted to show you how to do that in case you wanted to compile your code without uploading it. Once the code is uploaded, you have the done uploading message at the bottom, and nothing happened. Right, believe it or not, that's on purpose. So all this code did was print something to the serial monitor. And so to be able to see what it is that we've done, we need to open the serial monitor. And so to do that, we want to click on this magnifying glass in the upper right-hand corner that says serial monitor. If I click that, I have the serial monitor opened, and sure enough, I have a message. It says, I wrote some code, but this is really fast and really hard to read. Let's see if we can fix that. Now, instead of serial.print right here, I'm going to switch things up. I'm going to write print line with an LN. I know it looks kind of like a 1. I know it looks like an I. That is a lowercase l. So the command is serial.println. And what that means is it's going to print a new line of code or a new message in the serial monitor every single time that we loop through. So let's go ahead and see what happens. I'll press upload. We'll open up our serial monitor. Sure enough, now our message is printing one line after another. Now, that being said, this is still printing a little bit fast. So let's go ahead and add what's called a delay. So I'm going to write delay 1000. And now the delay command is really cool. So what this does is this pauses the code before it moves on to the next line. Now, since this is the last line in our void loop, as this loops over and over and over again, it's going to print, I wrote some code, then wait for a second, and then print, I wrote some code. So let's go ahead and see what this looks like. Okay, sure enough, every second we get our message, but this is a little bit too slow. Let's try making this a little smaller. So like we said, the delay command uses milliseconds. So if I have 1000 milliseconds, that's equal to 1 second. And so let's say I have 200 milliseconds. That's like 0.2 of a second. So now if I open up my serial monitor, here we see we have the message printing faster. It's all on a new line. It's nice and easy to read. We are all set. So like I said, whenever we start messing with sensor data and things like that, having these messages print in a serial monitor is going to be really, really helpful. So that's enough of the serial monitor. I say that we move on to circuit number 2 and we start interacting with the real world. So like we said, the main point of this first chapter is to start to learn how to control light. So we're going to start with a single LED. So if we take a look at page 15 on our book, we have our very first circuit right now. Here, unlike the previous example, we're actually going to interact with the real world, and our goal is to light up this LED. And so there's a few things that we need to know. The first thing we need to see is that we have a blue wire going from pin D3 over to our LED. Now we've also, this time, plugged the Arduino into what's called a breadboard. Now breadboards are awesome. They allow us to make all kinds of electrical connections. And so there are two really important things to know about breadboards. One is that the outside row of a breadboard is connected. It's like one long wire. The same with this outside row. There are 4 outside rows that allow you to connect all the way along, and we usually use these to control power. That's why there's a blue and a red, like a negative and a positive, although you don't have to use them that way. But here you see I have a negative going to a resistor. So if we look at the top part, I have pin D3. Now my goal is to have positive power flow out of D3. Then I go to an inside row on my breadboard. And you see these rows are not connected all the way down. They are connected like columns. So in this example, the green highlighted holes represent electrical connections. And so you can see I have a wire going from D3 into this row, which then goes into my LED, through the LED, into this resistor, and into ground. Now in engineering, we call the negative ground. So if you were to think about this like a battery, the positive would be pin D3, and the negative would be the ground pin. Now we represent ground GND, it's often abbreviated like that. And so here we have our first complete electrical circuit. We have positive power flowing from D3 through our LED into a resistor, which resists the flow of electricity and protects our LED, and then into the negative or ground. Now this is really important. We have a diagram of this in the book, but if you look really carefully at your LED, there is a longer side and a shorter side. Now on a standard regular LED, the long side is positive and the short is negative. And so when you're plugging your LED into the circuit, make sure it's the long side that's facing this wire and the short side that's facing this resistor and then going into ground. Let's go ahead and build it. Now that we have our circuit built, it is time to write some code. So if you think back to the circuit, we plugged the positive side of the LED through a wire into pin D3 on our Arduino, and the other side went into ground. So one of the first things we need to do is set up a variable for our LED. So this time we're going to write our variable above the void setup. We're going to see that that's actually really common. We mentioned before that the code above the void setup doesn't need to be in brackets. But we're going to start off by creating our very first variable. I have int LED equals 3. Now this is a variable, and it's a variable with the value of 3. Let's go ahead and take a look at this so we can see what all this means. So the first thing we have is int, and int stands for integer. And so whenever you have a variable, you have to declare what kind of variable it is. And since the value of our variable is the number 3, we want to make it an integer variable. So I have an int type variable, and I'm going to name it LED. Now, you could absolutely name your variable whatever you want. I'm keeping this as LED to make it nice and easy. So the Arduino doesn't know what an LED is. Again, I could name that anything, but I'm going to stick with LED for now. Now, in this case, the 3 is referring to pin D3 on our Arduino, which we plugged our LED into. The last thing I want to talk about is the semicolon. Now, more often than not, we want to make sure that our lines end with semicolons. There are some exceptions when it comes to things like loops and conditional statements, but other than that, make sure you have that semicolon. Also, you want to make sure you don't type a regular colon. Now that we've got our variable all figured out, it is time to head down to the void setup. So in the void setup, we have a really important job. What we need to do is we need to make sure that we declare our pin as an output. So I have the command pin mode, then our variable, LED, output. So I'm declaring this pin as an output because we're not trying to take in any information. We only want to send data out. We want to send some voltage out. And so because of that, we want to declare our pin as an output. Now in our void loop, this is where we have the main part of our program, right? This is where our program is going to loop over and over and over again. And so if our goal is to turn 5 volts on pin 3 and then send that 5 volts to our LED, I want to start with the digital write command. I have my variable and I'm gonna write high. So I have digital write LED high. What I've said is, hey, Arduino, I want you to turn 5 volts on to that variable that I mentioned. And the Arduino says, okay, cool, no problem. So now with this command, I have turned 5 volts on pin 3. I'm gonna go ahead, I'm gonna wait a second with a delay command. And then I'm going to turn the LED off. And so the digital write command is awesome. It allows us to turn positive voltage on or off. So if I write digital write LED low, then I'll have 0 volts going on and our LED will be off. And so this will allow our LED to turn on, off, with a second break in between. Once you have that code written, let's go ahead and let's upload it. And if everything went as planned, you should start to see your LED blinking on and off, waiting every second. Now that we've got one LED going on and off, let's see if we can add some more. All right, so with project 2 out of the way, let's go ahead and move on to project 3. So project 3 is extremely similar. The only difference is we're adding 2 LEDs. And what's cool about that is it's a great opportunity to show you guys how to add in extra variables. What's so cool about this course and this ebook is that any of these projects individually can all be combined. And after all, if you combine light, sound, and motion, like we said before, that's how you can start to build up these robotics projects. And so in the same way that we go from 1 LED to 3, we can do the exact same thing to add in motion or add in sound. And so the process is really easy. So here you see that, like before, we have pin D3 going into the positive side of this LED here. And all we've done is we've added a wire onto D5 and D6. D5 going to the positive of this LED, D6 going to the positive of this LED, and them all having resistors and going back into ground. Now, the only weird thing is that we skipped D4. And I'm gonna talk more about that later. But for right now, let's go ahead and give this a shot and build it. Now that we have our 3 LEDs wired up, let's go ahead and add them into our sketch. So here was our original sketch. We had int LED equals 3. And so what I'm gonna do is I'm gonna switch this up a little bit. I'm gonna write LED 1. Now to add in more LEDs, all I have to do is add in more variables. So here I have int LED equals 1, int LED 2 equals 5, and int LED 3 equals 6. Now, in my void setup, I've got to label the other LEDs as outputs. Now that I have 3 variables created, and the 3 pins we're using declared as outputs, in the void loop, I can tell it to do whatever I want. And so, the way that I have this now, I'll have all 3 LEDs lighting up, and then all 3 LEDs off with a second break in between. Once you've got that written up, let's go ahead and upload it and see what happens. All right, if your wiring was correct, then you should now have all 3 LEDs lighting up and then turning off. Now, this is okay, right? But what's so cool about Arduino is we have the ability to switch around our code and have something completely different happen. And so now we'll go from having all 3 light up and all 3 turn off to having them turn on one at a time. And what's cool is it's a pretty easy switch. Let's Let's give it a shot. So now instead of, I have LED 1 high, LED 2 high, LED 3 high, I'm gonna go ahead, put in a delay. And this time, I'm gonna have a pretty small delay. And then, I'm gonna turn LED 1 off. Then, I'm gonna turn LED 2 on. Then, I'm gonna wait another quarter second. I'm gonna turn LED 2 off and LED 3 on. Then I'm gonna wait another quarter second and I'll turn LED 3 off. So now if I were to upload this code, instead of having all of the LEDs turn on at one time, I have LED 1 on, then a quarter second later, I have LED 1 off, but LED 2 on. Then I wait a quarter second, I have LED 2 off, LED 3 on. Then I wait a quarter second and I turn LED 3 off. Now because I didn't put a delay right here, this line of code will happen just, a fraction of a second after this code. And so we end up having all 3 lights going one at a time, this time much more rapidly. Let's go ahead and upload this example and see what happens. Sure enough, we have our lights going one at a time, much more rapidly. All right, so we figured out how to add in multiple variables and multiple LEDs. We have 3 LEDs, 3 variables, great. Now it's time to add in another component that's really cool. And in a lot of ways, it's like 3 LEDs put together. I'm talking about the RGB LED. And what's so cool about the RGB LED is that we have a red, green, and blue channel. And with a little bit of code, we can turn the red, green, and blue values up and down to start to mix colors together. And what's awesome is our code looks really similar. Let's take a look. With the start of Project 4, we introduced the RGB LED. And like we said, the RGB LED is 3 LEDs put together. Unlike a standard LED that has 2 pins, here we see we have 4. 1 for red, 1 for green, 1 for blue, and 1 for ground, or negative. And so, if you think back to the original LED, we mentioned that the long side was positive and the short side is negative. Now on this style RGB LED, the long side is actually the negative. So you have 3 shorter wires and 1 that is the longest, and that is going to be our negative. And so if you look at our circuit, it's really similar. We have a wire going into ground, and we have pins 3, 5, and 6 going into our RGB LED. So in this example, I have red, my negative, green, and blue. So I have red on this pin going to D3. Now in this case, I'm using a resistor kind of as my wire, right, instead of a wire. I have D5 going into the green channel, and I have D6 going into the blue channel. So we have 3 forms of positive voltage with our 3 digital pins, then going into the negative through this black wire into ground. Let's go ahead and build it. So once you have the RGB LED all wired up, let's take a look back at the code from our last example. So this code allows us to have 3 LEDs, right? And we had 1 going after the other. And so what's really cool is all we really need to do is change the names, and we can make this work for our RGB LED. Let's take a look. Instead of LED 1, 2, and 3, I have red, green, and blue. I need to declare them all as outputs, just like before. And so we see that if we have red on and then red off, green off, blue on, and then finally blue off, we get a very similar sort of sketch, right? We didn't change anything other than the names of our variables. What's so cool is, even though we could re-upload this code, we really didn't change anything other than the names. And so if you hadn't uploaded other code since our last example, then your actual RGB LED should already be working. And that's just a cool example of how the code stays on there until you upload new code. Now, making an RGB LED shine red, green, and blue all in the same LED is fine. But one of the coolest things about the RGB LED is being able to make custom colors. And so now what we're going to do is we're going to take a look at a totally different command that's going to allow us to do exactly that. So let's say that I wanted to make purple. I've got a few options. You can imagine that I can turn on red and blue at the same time and get a purple color, and that's true. But what if you wanted to mix these colors together a little bit more? Now, the digital write command allows us to turn 5 volts on and off. But if I change this digital to analog, I actually have a lot more control. So the analog write command is awesome. If I change this value from high to say 255, and on the bottom make the blue 255, I have said almost the exact same thing. So the analog write command is so awesome because it allows you to control exactly how much voltage gets sent out. And so if I write 0, that's the exact same thing as saying digital write low. If I write analog write 255, that's the exact same thing as saying digital write high. But I'm not limited to 0 and 255. I can write whatever number I want. Let's say I want a lot of red, a little bit of blue, and just a hint of green. Using the analog write command, I can do exactly that. And so here you see, by using the digital write command, we can turn on LEDs. But by using the analog write command, we can control exactly how much voltage we send. And using that, we can create all kinds of awesome custom colors. All right, just like that, we've reached the end of chapter 1. So we hope you guys had a blast learning about controlling LEDs with the Arduino. Obviously, there's tons more you can do that we don't have time to cover here. So the last sketch that we cover in the book is this sketch you see right here. So fading through the different colors of our RGB LED. So we don't have time to go over that in detail right now. But it is in the ebook. So if you haven't yet downloaded that ebook, be sure to head to anyonecanbuildrobots.com so you can get this as well as the other chapters. And along those lines, we're going to have the video for chapter 2 and 3 out really soon, so keep an eye out for that. As always, thanks for watching, guys.